Hi to all. This is Dr. Jana Prasad welcoming you to this class. This class is all about confusion matrix for machine learning. To understand this topic is required to all of you to know what exactly meaning of the classifier is. Generally, a classifier is used to predict an outcome of a test data, and the classification is the process of predicting the class of given data points. Classes are also sometimes called as targets, labels, or categories. And the classification predictive modeling is a task of approximating a mapping function f from input variables x to discrete output variables y. So generally these type of the classifiers very useful one for us to go for the predictions. And the predictions is a very useful one in many applications. Some of them are business forecasting, cause and effect analysis, stock market prediction, weather forecasting. All these things are possible in the predictions. Generally, you will find so many classifier algorithms in the machine learning, but at the same time, it is required for us to measure the performance of all these algorithms. To estimate this type of algorithms, there is a concept introduced that is called confusion matrix. So, to understand this confusion matrix, let me explain about the basics about regarding this particular matrix is. It is a predictive analysis tool, and specifically, it is a table consists of rows and columns that displays and compares actual values with the model's predicted values. Within the context of machine learning, a confusion matrix is utilized as a metric to analyze how a machine learning classifier performed on data set. A confusion matrix generates a visualization of metrics like precision, accuracy, specificity, and recall. These things would be explained in the coming slides. Let me explain the how do you represent the algorithm in the confusion matrix, the results of any algorithm in the confusion matrix, and how to estimate that the algorithm performed very well. The reason that the confusion matrix is particularly useful is that, unlike other types of classification matrix, such as simple accuracy, the confusion matrix generates a more complete picture of how a model is performed. Only using a metric like accuracy can lead to a situation where the model is completely and consistently misidentifying the one class, but it goes unnoticed because an average performance is good. Meanwhile, the confusion matrix gives a comparison of different values like false negatives, true negatives, false positives, and true positives. Explain you what these are all two values are. Here now the representation is available here. You can see that. So what you have is called here, this cell represents true positives, TPs, false positives, FPs, false negatives, FNs, and true negatives, TNs. On top, you can find out actual values versus predicted values. So actual values you can here now call represents 1, predicted positive values represents 1, and actual negative values are zeros and predicted negatives are zeros. So this is the way it is possible to represent these four of them. Then what is meaning of TP is? So there are generally two values identified. There is actual value exists as well as predicted value exists. Suppose example, what you have is called here now actual value 2 plus 3 is equal to 5. And we also predicted 5. And these three values have been given to the algorithm to know the result. The algorithm has given the value called 5. So whatever you have predicted and actual value both are same. So this is the way it is possible you can get that here now. At the same time, if you are asking call 2 into 3 is equal to 6. So actual value is 6 and predicted value is also a 6. And this is showing. So this is called true positives point of view. The meaning of true positive is predicted value is correctly predicted as actual positive is. Suppose now you are estimating that the rain would come based on some values. So predicted value is called there is going to be rainfall within 1 hour. And here now called on the algorithm, we have given all the inputs. And this is algorithm set is called no rain. The actual value, what you have set is called rain comes out, right? Rain comes. So predicted value, what has come is nothing but they call no rain. So this is the difference comes out here now called. That is nothing but they call here now is nothing but they call predicted value is correctly predicted as actual negative values. So these are the things comes in the picture: TP, FP, FN, and TN. TP is called true positive, where predicted value is correctly predicted as actual positive values. Predicted value FP is predicted values incorrectly predicted as actual positive. Negative values predicted as positive. Fn is false negative, predicted values predicted as negative. True negative, predicted values correctly predicted as an actual negative. So that representation is possible using this way. F plus plus, true positive, F plus minus, false negative, F minus plus, false positive, and F minus minus, true negative. So these true positive, the number of instances that were positive and correctly classified as positive. The number of instances that were positive and incorrectly classified as negative is also known as type 3 error. The number of instances that were negative and incorrectly classified as positive. So this is known as type 1 error. True negative means the number of instances that were negative and correctly classified as negative. It's called true negative. So all these four will be represented here. Let's define a matrix that a complete matrix represents is. Let's go further. This one is. After a representation of all these things, here now you need to find it out. This is called total values is. So number of positives are F plus 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 F plus minus. The total number of positive instances. Number of negatives means called F minus plus plus F minus minus. The total number of negative instances. N is nothing but a call that about some of the two of them that are NP as well as NN. Number of positives and number of negatives. The total number of instances. While if you come to TP and TN denote number of correctly classification, while FP plus FN denote number of errors in classification is. If both the values of FP and F1 is equal to 0, that means there is no question of type 1 and type 2 error. False positives and false negatives equal to 0, that means all of them are proven true only. So this should be here now, always should be 0 value. That means TP and TN always correct value. So we are going for correct classification. Now call another example, you can see this is called. So this is called actual sick. This is one of the example, ID1, actual sick, predicted sick, and outcome. So ID1, actual sick is 1, predicted sick is also 1. The result can be taken as true positive. Okay, you have predicted called 1, okay, and actual sick is a value called actual sick, and the algorithm also performed called 1, is a true positive. Actual here now called sick is 0, okay, predicted also 0, is called true negative. And here now called 0, actual sick is 0, predicted sick is also 0, true negative. Here now comes in this one is, so 1, 1, true positive, and here now 0, 0, is also true negative. This is also 0, true negative. Here now comes out. Actual sick is called 1, your algorithm predicted that is 0. This is wrong here. That's why it's called FP, false positive. When you got 1, 0, the result is false positives, right? When you got 0, 1, it's called false negative. Of course, what we're saying here now, this both should be 0. This number of instances should come out for FP and FN should be 0. Whenever you have encountered these values called FP and FN, that has come in the outcome, that means called this particular algorithm is not performing well. So in this case, what you have is called in 10,000 cases, for example, what you have is called the total outcome values. So from the above table, it is possible for us to know here now called. The accuracy is possible for us to find out like this. In this one is called total positive plus total negative, you are writing in the numerator, and denominator represents the total of all these values are. When we have seen this is called 30 plus 930, total positive plus total negative 930, divided by 30 plus 930 plus 30 plus 10. So if you done this, and the answer comes to 0.96. The percentage is called 96%. So that's the reason that is called the answer is called here now. 96% is coming. So it should come out called 100% should come out, but here now 96% is coming. So it's not bad, means come here now algorithm in the trial and error base. So it's not bad, but at least you should see that it's 100% should come out.